What about this? What about this? It looks better. Is it better? I don't know if it's better. It might be better. I see things. I think it's the same URL still. It says nobody's waiting anymore. It's updating all of my stats. This might be working. Tell me if it's working. Tell me if it's working. Dabba-doo, dabba-doo, shabba-doo, gabba-doo-wabba-doo. Because it says viewer no longer waiting. So everything should be fine. But if it's not, you gotta tell me if it's not fine. Let me double check the... If I copy URL, does the URL match this one? I think it does. Yeah, it's the same URL. So we should be live. Let me refresh my stream, make sure. Why are there always technical difficulties? Why you gotta go and have so many difficulties? Alright, we're just gonna assume that it's working, because nobody's telling me it's not working. Okay. We have some more expressions and statements to parse. I'm going to try to get all the expressions done first, probably. Start working through all the primaries. There's a few to continue with, and then statements should be easy as hell. The hardest statement is going to be the for loop, probably. It shouldn't be like, oh my god, I know I'm live. Don't. So many emails. So many free mails. Tell me. You forgot your Streamlabs Ultra subscription? Don't. God, I need to just, like, immediately delete my Streamlabs account because it didn't fucking work. Didn't fucking work. Alright, so binary expression parsing, complicated as it is, I think works. We'll have to come stress test it later, but this will be fine. So let's go to primary expression. All of these are types. We're probably going to want more built-in C types pretty soon. Just not right the hell now. That's going to be a to-do for somewhere. We're going to say types, additional C primitives. Yes, I've got that. So let's just, I don't know. This was float 128 was an example. I don't remember, actually. There's more. I just want to put stuff there. Okay, so we've done the grouped expression. Done. We've done the name ref expression. Done. We've done a single literal integer. So, done. So what we want to do is, for literal everything else, string, rune, int, float. That should just return the token. So, I mean, we've done I'm just gonna mark that as done. String, rune, done. Okay, easy. We skipped float because we don't actually have floats, but I did the thing where I put it in the AST. Bool literals can also just be true, false, done. We did bool literals. We're halfway through the list. Let's go. Invalid empty expression. So what I want to do for this is if we hit any token that cannot ever start an expression and is usually like a terminator, it's going to just definitively crash, probably, which might just happen by default. If I go to default and instead of throwing an ice, we just say expected. So context.diag error at current location. Hello, Hunter. Expected an expression. And then we can just return new token missing new location, current location, offset 1, source file ID. Boom. Expected and expression. Now, here is the problem. If I don't skip over the current token in the expression parser, I need to make sure that we don't infinitely loop trying to parse something like an expression. So somewhere higher up in the parse hierarchy, I'm going to need to make sure we skip a token if something bad happens. But for right now, the expression parser is not responsible for that. So let's continue. We need, that's technically correct. It's just going to return a missing token, which is an invalid expression for now. Cast. So here's the thing. I know the default cast syntax is going to be, we can do it along this shit for now. We can say like, I8 A is cast, I8 RXE. That's the default cast syntax. So this could even be var. I would like an autocast syntax, which might just be cast var. Or an empty thing. If I just say cast, maybe, then this becomes auto-casted to whatever its target type is, if possible. So those might be the two things that we do, is say cast I8 and that. That doesn't make terrible sense. Cast. So we want to, if I say advance, I still have access to current token lowercase, which is the cast token. Which I can just do with the capital C though. So let's return new syntax extra cast, which is going to need token cast. It's going to need the target type, which could be null, and it's going to need the expression, which is a primary expression. So expect open paren, and then expect close paren. Then if not at token close paren, syntax node target type is null by default, then target type is parse type. Easy. Then we expect the close paren. Then we say var expr is parse primary expr, and we return a cast. So in syntax expressions, before types, for types. Okay, so then the children we're going to do dynamically. So that's going to be get that yield return token cast expr, and the target type is not null. Type, boom, and then do I have anything else to override? It's not a declaration, it can't be a type. I can just do public bool is autocast target. well. That. Okay, that gets me cast. I don't have actual declarations here just yet. So let's do that. This. Okay, so we have cast and cast. This cast doesn't have a type. This cast does. It has the type I8. It has argc. I need to fucking need to do my sized types actually, so hold on. Let me go back to the Lexer before I forget, because I keep forgetting. I need keyword tokens. If this, else, we want to do a thing. The thing we want to do is, does it start with if token info dot text sub 0 is I or, let's start with B or I or F. And the entire substring, what is, oh, else if this, then do I want to do the check here? Because I don't really have, if I then say, okay, I can do this, and then I can say and token info dot as span, not text, value span, slice 1, int start dot all. Is it all? Because it's any. We don't want any, we want all. If every subsequent character, like why don't I have, do I not, like I'm probably not importing link, that might be all. Might be why. If I say dot all, link should come in. Why don't I have this? Why doesn't it exist? Aggregate many? Wait. Aggregate might work rather. Because it's a read-only. This is a span of character. I'm assuming that I can do enumerable things to this. So if I said I enumerable car this dot all, there, but I can't do that. Cannot convert read-only span to enumerable, which kind of sucks. So I think I'm gonna have to implement my own function for this. I thought you could do that. It's interesting that you can't. Didn't want that. Didn't want that either. So put me at the top, coach. It doesn't inherit from anything. Interesting. Okay, well, I mean, there's gotta be a way I can do this without writing my own. If there's not, that's fine. Because I could select get enumerator. If I got enumerator, that like doesn't let me do anything now. So it can be enumerated, it's just not an enumerable. Ends with enumerate lines. Why isn't this provided? Only white space characters. But I can't select either. They don't want me to select. Okay, we're just going to write our own extension function for this. So we're going to say all C is digit, syntax facts is digit, C, which then just gets transformed into this. If all of the above. Right. Yup. Hello. Do I have extensions that I care about already? No, maybe color extensions. So just in fucking choir driver, this one's gonna be ye old-fashioned read-only span extensions .cs namespace choir public static class read-only span extensions public static bool all t read-only span t dot gad s. So then I want to say I need a predicate of t predicate sure, and then for int I equals 0, I is less than s dot count length I plus always gotta check. If not, predicate on s sub I false return true. That's all I wanted. That's all I wanted. Now I can do the thing. And it's going to want me to do one dot dot probably, so that's fine. I'll do it. If this is the case, then we're going to say, hello buffer. How's it going? I'm fighting C#. We want var token info kind equals this switch b token kind bool sized int sized float sized fi. So then we want to say I'm mostly okay. I feel a little strange today, but it's nothing bad. Nothing bad at all. So I want to have a range of values we can support. I think the maximum range, or like the range we want to support, is 1, 655, 3, 5 inclusive, right? So we can just say if token info text value dot length is greater than 1, 2, 3, 4, 5, 6, right? Is greater than 6, then it's just flat out of range. So then we're going to say context diag error, and that's going to be at the current location. Do I have position here? I do. So I can construct new location token info position 1 source file ID, boom. What we're doing is the sized primitive type sized primitive bit width must be in the range 1 to 6553. We'll call it 65536 like that. So it's just not. That's just a thing. Right? Else we could be in range, so I'll say int bit width is going to be just regular int parse, because we know it's going to be valid, out of token info text value as span 1. Then if bit width is less than 1, I have to say is less than 1 or greater than or equal is greater than or equal to 65536, then report the same error again. Else token info dot integer value equals bit width. Can I do an implicit conversion? I can, because we're using big integers. Okie dokie. So in this case, we have decided the kind is the kind is the kind. This is unreachable. This is like a little ugly, but I just, it's fine. Because what I could do instead to make my life easier here is turn this into brick, I guess. And then, no matter what, again, to make my life easier, we could just do this. And then, actually, just do there. So I don't have to unwrap that value or compare it to weird things. So there we go. That gives us sized types, which should now just exist. So if I go back to parsing, this should change what these types are, if I didn't break anything. So now instead of being an identifier, this is a built-in type, I8. So it did start parsing and not yelling at us. That's good. Size types. Cool. Now, we were finishing up the cast. I think the cast is done, actually. So we can do constructor. All the unary stuff is going to be so much easier. So I'm still not sure how this language is going to handle the ternary expression, by the way. We will have to see. Because question mark can go in a type, and types can go in expressions. So yield, yield, where is it? I put it in here somewhere, this one. The question colon typical ternary expression might be a difficult thing to parse. So I might just not do it. But we will see. I haven't started parsing nillable types yet. They are continuations here. Nillable has not been parsed. I think we've handled pointer and reference and correctly, and we've started handling buffer and slice. But I need to check all of these, so I've left them unchecked for now. It's not that hard to parse IMO. I mean, define, because I could make if an expression. I don't necessarily want to. I could. If might be the only thing that's an expression, basically. The reason I think it's hard to parse is because if foo question mark is a type, bar, I'd have to look kind of infinitely ahead, maybe. I mean, I could do. It's very low precedence. It does, but. So, I mean, what I could do is, as soon as I can do kind of what we're doing. Yeah, this is what I mean. This is. Yeah, just do if expressions then. That's basically what I'm thinking, because this might be more of a reason. I mean, the reason not to is familiarity with C. We are trying to maintain some level of C familiarity, and if expressions are not a C thing. Granted, I'm doing a lot of things that aren't C things, but right. So, because what I'm thinking, if I wanted to try it, what I'm thinking is we do something similar to what we've done with the declaration parse, where as soon as we hit a star, it's going to check for an expression on the right-hand side. Problem being that I just don't want to handle all of the potential cases that could come up, I don't think. So I'm going to stick with if expressions. Maybe we switch to the ternary eventually if I can figure out how to parse it. I don't think we're going to do dictionaries. I think that's going to have to be a standard library type. Tuples I'm still 50-50 on because I have to parse them. So let's do var should be trivial. It should just kind of exist. It's a built-in type. I've already got it set aside. Parse type. Let me just make sure that var is returned while I'm thinking about it. Case token kind var advance is going to return a built-in, maybe not. What do I want the syntax of var to be? Because it's not a type. So it doesn't have a type. So I think this is going to be type node equals new syntax. Or even better, actually, it's a type. We can just type node equals current token, lowercase, break. That'll be fine. Okay, back to expressions. We did, I'll mark that off as probably done. Did I add the size primitives? I think I did. Sized. Okay, those are good. Back to expressions. We were doing cast, we finished cast, unary operators. Lots and lots of unary operators. Cast is a unary operator. Case, token kind, minus. And I'm gonna have to do a thing sometime soon, probably. No, I don't think I do. I was doing it in the previous parser here because I was trying to keep track of types in in here, in primary expression, I was trying to keep track of potential types for things in the syntax tree because it was the same tree. So we did a lot of guessing here. We did a dereference and tried to guess if we could dereference the type at parse time. We're not doing that anymore. Fucking not doing that. So I don't actually have to do anything all that complicated for a bunch of unary types. Minus, plus, which I guess can go this direction, star, ampersand, minus, plus, tilde, ampersand, star, and then not. Those should all be advanced. Var token operator is current token. And var expr just gets to be, parse parsing a primary expression here. Then we just return new syntax expert. C# mode is not working for me. Unary token operator expert. So back into expers. Public sealed class syntax expert. Unary syntax token operator. Syntax node operand is a syntax node at token operator.location. Public syntax token operator. I can actually just steal that from here. Public syntax node operand get override children. It's going to be token operator operand like that. And now we've got all the unary operators. It's amazing when things go easy, hopefully. Right? That should be all of those. Now, that's technically not unary. That's a ternary operator. So we'll mark off all the unary operators. I still have a constructor and a ternary operator. Do I want to have separate ternary parsing rules for if as an expression? Maybe. I say that because if I want if to be an expression by Laye's expression rules that we're going with, it's going to be verbose as hell. So I might have a separate ternary syntax for if expressions. So. I've got a couple things running through my brain, sorry. There are... Right, because I already am going to have a different syntax for compound expressions. It's just going to be the same syntax, but it starts with the keyword do. So I'm kind of justified in saying that there would be a different expression syntax for if then else. I'm going to stick with that for now. Case token kind if. And here's what's going to happen. What I'm thinking is if statement requires both the parentheses around the condition as well as the block. Compound here required. If expression is if condition then. And it requires both the then and the else. That's my proposal. Proposal. I don't know how I'll do happy error reporting for that yet, but that's fine. So if, let's do, here's the problem. I technically can't, even if I say like foo and, did I have and? I did. Yeah, foo and. If bar, then baz, else cucks, quacks, whatever. That will be the thing I'm trying to parse to get this to work. So advance bar token if. I didn't ask something necessarily, but if you wanted to feedback on my proposed, I was just working through in my head if that made sense. Token if equals current token, and I think what I said I wanted to do was do this to see if I even need this temporary variable, because I might not. So advance past if var expert condition parse expression in default context expects the keyword then. Do if maybe? I don't hate that. Requiring both is render redundant. IMO requiring do and if is what you're saying. This is redundant. Why did you suggest it? One or both. Oh, you're talking about if this, and I'm requiring both. Oh, and then you're saying do if, but the same syntax. And then this is an expression. That's what you're suggesting. I don't hate that. That gives me multiple conditions for free because I don't have to invent a new else, if, then handler parser. So, and then the reason I'm requiring both delimiters is just kind of preference and parsing safety, because this, in an expression context, is a constructor. So if foo, this is the whole condition, and there's no body. So to prevent that, we provide this. Then I don't have to require this, but I kind of want to. For preference purposes, I might make it not required. I don't know yet. Maybe we don't require it. We'll experiment with the parser, see if I don't have to require it. At the first sight of issues, we're requiring it, but this should be fine. So let's, here, advance past this. Token do, just in case I need it. So then we want var if, expert if. No, you don't like do? What? Need more context. The one below it. The one below what? I'm on as low latency as I can be. I don't know what the latency is, but maybe YouTube will tell me what the latency is. Stream is healthy. That doesn't tell me anything. Stream is on low latency, it says, but it's not telling me what it thinks the latency is. Stream status is excellent. Sure, but like, tell me what the connection, what's the latency? Here, let me just look. If I select this block of text, that's only like 5 seconds. So not with do, just remove do entirely. You don't think do good. Sure, why not? Let's try it. Let's see what happens, charade. Case if. And I'm just going to return parse if. That's just going to be a thing we have to write now, which is going to handle all of our if. So we'll have an if and then a I can maybe hold on. There's some errors I can do syntactically. I'm just going to return it for now, but I should be able to do some error reporting based on syntax stuff. So then I can say false and this, else that. Those are the two things we're going to try to parse. This requires a semicolon because it's an expression. This does not because it's a statement. So let's go parse an if somewhere. Where do I want to put parse if? There's parse type. We want it above parse type. Type continuation template arguments. We can get rid of that now. We can get rid of this now. You're reacting to messages I wrote 2 minutes ago. What the heck? The latency should not be that bad. Like over here, if I was about 6 seconds on my end. You probably rewound. You may have accidentally just paused the stream or had the playback fuck up. Because I'm only seeing 6 seconds of latency on my side. Okie dokie, what was I doing? Where do I want to put if? That's right. Name ref, it's going to be above name ref. It might be right around compound. So private. That might have been it, yeah. Syntax node parse if, which can really be syntax just if, because it's neither a statement nor an expression. It's just going to be if. So I can put it in statements, I guess, but it's not really either, so that sucks. Let me put it in syntax node. Yeah, I got to that eventually. Another thing I want to think about is, do I give a shit? I think I do. We're gonna keep track of all of the else's. So let's take if the actual conditional part. Naming things is hard. What I want to do is say that an entire if plus body is a syntax node, and then within a bigger thing, else is a separate thing. So that it's if body, and then else is a separate thing. So if, but then we have like if condition. So then I can say an if condition. I can rename these later, it's fine. There isn't really a good reason to do if foobar with the things, though. I mean, I don't think I'll make this mandatory. The reason is just to prevent funny expression things happening, which they might not. It should be fine in this context, so I won't make it mandatory right now. I just have a fear it might be necessary. The way my syntax works makes this very confusing, so I just don't know for sure. So then what I want here is syntax if condition I read only list of this conditions, and then syntax node. Why does conditions look like it's spelled funny? What did I do? I think it's fine. Syntax node. Else body. Something like that. Syntax node. So this whole thing can just be at conditions.length count 0. So then that would actually, I could totally, no, that's fine. Or conditions application. Boom. Override children. Get for each var condition in conditions yield return condition if else body is not null yield return this body. And the reason I want to do that is because I always want access to the no condition case for purposes of checking on expressions. So then this needs syntax node condition, the actual condition, which is why I don't like this name, and then syntax node body. So then I can just do condition body, condition body, and then okay, public. So add token if. Then I can add for symmetry that should be everything I care about right now. Then I can call it like if primary, so that I'm not too terribly, like that's just for me, so I'm not too terribly confused. This is going to return syntax if. So debug assert question mark. We shouldn't ever call this if we're not already at an if. Boom. And actually, before we go parsing an if here, it's been almost an hour. I'm gonna go take a break, come back in a little bit, see if my break text still works. It does, I didn't break it. Okay, I'll be right back and then we'll parse ifs. It is no longer break time. For now. It is no longer break time for now. Okally dokally. Okay, so what I want to do is actually that's going to go here. While at token if. So actually do var if primary parse if primary. What the heck? While not is at end and while here's what we're going to do. While we're at else. Right? Question mark. But what we want to do then is not this. So let's copy, paste, say var primaries, then parse a primary, which should be correct, so I can just do repeat, that's fine. Then while at else, if at, we're going to advance actually, while try advance out token else, if at token kind if, then primaries add parse if primary, else var else body equals parse statement, which doesn't really exist. So if I go look at parse syntax in statement context, this is allowed to parse declarations. We don't want that. We want, let's just say, private syntax node parse stmt straight up is going to be going to do this, and it's not going to allow for declarations, and it's not going to do that. Okay. So then case things like return parse stmt. That'll come over here for sure. Then both of these need to have a shared from an expression, which is then going to do this, which is then also going to have this eventually when we get there. So then this just needs to return parse continue expert. Oh, syntax. Right. So then this is an expert, and we can return parse stmp continue expert. Okay. Both of those will come up here, but this has additional checks for declarations. Okay. So we'll get to statements eventually. Here, parse a statement and break, because what we're going to do, actually not even break, just straight up return question mark? No, we can do syntax node else body, which is null by default. Else body is whatever this is, break. So instead, no, I don't like that. Var, we're going to just return use syntax if primaries to array, which it's gonna actually require me question mark. It's gonna ask me to do something. It's not. Okay, not here. Token else body. So then here, if we don't hit else, then we just return the thing to the array. No. So I have a little bit less to store. This one wants me to do the thing. So fuck it, we'll do the thing. So then parse if primary now needs to token if expect token open paren. Open paren. Expect a close paren. Var condition is parse any random expression in the default context. Okay. Then var body is parse stmt, return new syntax if primary, which needs token if condition body, right? So that parses an if. So then back in wherever the hell we're parsing the other if down here, we can then say if expert if dot else body is null, then context diag error at expert if dot location. Okay, so that gives us ternary if. Then case token kind do. We have do when peak at one token kind open brace. We're then going to go into statement and grab compound, move it to expression, and say expression compound. So then I'm going to say advance and then I can say var compound equals. I guess it really doesn't matter. I can just parse it as either, and it's fine. So if I just parse compound, and do that, and then I can rename this to just parse compound. It can be a statement or an expression. And then this just goes away. Syntax statements, syntax compound goes into syntax node as well. Boom, why not? I'm at. I like it, I think. To do a doc. Do expression. Done. So then we just have constructors. Case, open brace. This is a constructor. Okay. To parse a constructor, we var token open brace. There we go. And we can return syntax constructor. That's always an expression, so expert constructor. A constructor needs a few things. Go to syntax experts. Let's public sealed class syntax expert constructor, which isn't the only thing I need. We'll do syntax constructor initializer. Which could be one of 3 forms. So I think I'll have this be abstract and have the 3 forms be more explicit. So I don't have a bunch of overlapping things in the same data structure here. So location, to get syntax node location, easy enough. The constructor expression itself, syntax token, open brace. I read only list of syntax constructor initializers, inits, syntax token close brace. That will do for me. So I'll just set syntax node. The location will be token open brace location. Then I want, ooh, my head. Why does that hurt? Public syntax token. That's not good. Token open brace. Get token open brace. Token close brace. Public I read only list. Syntax constructor init. Inits. Get. Inits. So then override children. Get. It's going to be token open brace, inits, token close brace, and that's all I need there. Public sealed class, syntax constructor init, just value, positional, syntax node expression is syntax constructor init. Expert location, public syntax node. What language is? Well, I'm parsing, or sorry, let's start with, I'm writing this in C#. I'm writing C# right now. We are parsing a language I'm designing called Laie, and you'll see a bit more of that as we get to testing. Expert get is expert. If you want, you can go to my GitHub, which is in the description, to see. I guess it's not my GitHub, is it? It's the organization's. So github.com laie. So tree main test laie. If I send you this link, you can see what the language we're parsing looks like with all the tests from the previous repository. For example, is this a good example? And it's just regular arithmetic expression stuff. I don't know. None of these are really good examples of what the language is going to look like. So instead of test, you can go up a directory a couple of times into examples. There's some examples of using raylib. This one was never finished, but it's what it might end up looking like. Ignore some of it being ugly as hell. We had some bugs with constructors, or they weren't fully implemented at this point. this compiler is like half implemented, and we're halfway through implementing another half implemented compiler, so it's not perfect. This project is the choir project, though. That's on my GitHub, Nashiora/choir. Override children. Get. So we're just doing a lot of parsing right now, all the boring stuff out of the way. So syntax expert constructor now has a couple things. We are going to want to parse delimited and allow trailing is going to be a new thing we're doing. So we'll get to that in just a second. Positional is the first kind of constructor. The second is indexed, which will need the syntax node index. And the third will be field. It's not actually going to be a field name is the problem. I mean, I guess it could and or should be. I don't think I handled nested initialization in the previous compiler, but now I'm thinking I might. So maybe these two need to be folded together into a not this thing. I don't know. Because in C, right, if I have a constructor in C, which is not called a constructor, but you know, the initializer here, right, like foo f equals something. In C, you could do a.b.c equals something, which I might want to support. But, because the alternative is A equals B equals C 10, right? Like, that's the alternative. Do I want... Because if that's the case, that simplifies my current syntax tree, but means I have to add arbitrary sub-expressions, which can only be two kinds of sub-expressions, so maybe it's not terrible. Because it can only be this or a array index, a subscript, right? A, B, sub C instead. That could be a thing. So what that would mean for me is instead of we're in expressions here. Instead of what I did here, we would do this. And we'll start with this, which is going to need to change to get yield return expert. Yep. Syntax node expression. Expert is going to become value, and then we need an optional like initializer target or something. It's not really a target, but I don't know what else to call it right now. Yeah. And then I could hand parsing each of the targets, or I could just call the primary expression parser and say only some things are supported. Because really, it's only going to support terminal fields, terminal field names, identifiers, dot for field access, and array subscript for like array access or buffer access, I guess. Slice access. You have to initialize the slice and the buffer to something though, so that doesn't really make sense for those. It will only make sense for arrays. But it's still going to be a syntax, so I might end up writing a custom smaller parser to avoid having to check all of that at semitime. And for right now, we could just limit it to only parsing identifiers. But I may as well. Well, I will have to kind of do my own parser for this anyway, because we can have a subscript without a thing before it. So I guess we have an implicit, like, this thing to worry about. So maybe I do want to split this back out into 3 categories. But now if I do 3 categories, then I still can't combine the 2. I need to figure out how I want to store this. So for right now, we're going to have a constructor init not take any target, and we're going to go put a to-do down, because I can't, for the life of me, figure out how to handle the data structure for this. I have a few ideas, I just don't know which one's going to work right, so I'm probably going to have to delay the fancy constructor syntax just a little longer. So, I'll know what that means. So we're just going to not make this abstract for now. All of them are going to have a value. We'll start here. So let's say var inits is parse limited of parse constructor init, delimited by a comma, expected initializer. Sure. It'll end with a closed brace or a semicolon, probably. That's a solid maybe. And something I want to do is we don't allow specifying if the thing can have a trailing comma. So I'm going to say true. Go to parse delimited, say we will allow trailing. If we allow trailing, it must encounter a closed delimiter. So then everywhere else that I use this needs false. Because I can't make it default. Oh, it's here, okay. And constructor init has true. That's fine. So then I can say this needs token open brace, inits token close brace. It doesn't exist, but will here. So then inits needs a thing. So parse constructor init can be a now, can now be a function also. If allow trailing, let's say debug assert allow trailing, not allow trailing, or token kinds closers. What did I call them? Closers.length greater than 0. If allow trailing is specified, it must also specify closers. So if we're at a closer, that's fine. If not, allow trailing, do the error. Result do the thing. While we advance the delimiter. Cool. That should fix everything. What do we have here? This is also false. Then I now need to go, finally, parse constructor init. Like that, which then fixes what we've done at the bottom. For the time being, we're just going to say var expr equals, which can be value, expr value even, parse expression. In the default context, return new expr value location, expr value. And we'll worry about all the other fancy stuff eventually. This is at least in a way that we can expand it when we need to without breaking anything. So then if I say in test.lie, we have a couple things to do. This doesn't work yet. I mean, it will, it just will complain about a semicolon, which I don't want to give it. This, we haven't tested ifs fully yet. So, let's test that first. Does it take? Expected an expression, good, false. Then I expected a semicolon at 329 because it didn't parse the else keyword. So my if parser is broken. No, it's not broken. I'm just bad. Okay. No, this is correct. This is correct. Parse stmt, though, when we're parsing a statement, it's parsing a constructor, which is wrong, because it needs to be parsing parse statement in syntax. Okay. Case open brace. We'll go here. Then case open brace return parse stmt compound, parse compound, like that. This should give me compound without semicolon warning error. Okay. Statement compound is empty. This is statement compound, statement expression, binary, false and if. If primary has a compound, else has a compound. Okay. So if is now parsing correctly. I could then even do it in an expression context at a statement level. And this is wrong, it's never going to work, but that's fine. I should do an actual valid empty expression, actually. So I don't have to worry about it. Public sealed class syntax expr empty. Location, which is not super necessary. Syntax node location, which has no children. It just exists for the sake of existing. Go down to parse primary expression and case semicolon. Advance var location is current location. Return new syntax expr empty location. Okay. So then, while this is valid now, it will turn into not valid in a second. So what I want to do in parse stmt again is case token kind if return parse if straight up. So then here, if now we should get an expression, empty expression here. Error expected semicolon. Oh, okay. In a declaration context, we want to say if syntax is syntax empty, just return syntax because it's already got a semicolon. it's an empty expression, but it should probably be new stmt stm syntax stmt expr of this plus the token semicolon, which we don't have. So let me instead say this can only be syntax token token semicolon, which can then be a token semicolon application, then public token semicolon syntax token get. I'm not going to let it have any children, but then I can say syntax dot just so that the expression has it. Okay. So then we just need that. Now that works. If I do this, I believe. Sure, that's good, that's fine. It's a little bit iffy, but it's fine. Okay, so we've done if. Hold on, let me come mark this stuff off. We just, in the process of doing all of that, statements. We did compound statements. We did if. Then parse stmt. Yes, we did that. We did empty as well, but okay. Most of these are pretty trivial to implement. So assert's the slightly harder one, I guess. Not really, but kind of. Did I mark off constructors? Did I do constructors? I didn't do that. No, come on. Did do that, though. So we've done that. So that's most of the expressions I care about now. Except I didn't do these. We didn't do continuations. So I haven't done field access. I haven't done invocation. I haven't done element index access. So before we get onto statements, maybe I do that as well. Okay, that's what we want. That turns it into a type. So, in any other case, we will want to handle. We've kind of got some ambiguity here that should resolve itself. What I'm thinking about right now is array types overlapping with index or syntax, right? But that should handle itself the way we're doing syntax. So if I say i32 i32 is only ever a type, this will parse as a type, no problem. If I say foo2, foo could be not a type, so it doesn't parse as a type yet. It'll see this, it'll say that could be an array subscript operator, so it'll give us array subscript. But then I'm gonna have bar. Now it's no longer foo sub 2, it's 2 foos. So basically I have to say that an array subscript can be a type, so long as its element can be a type. Because in most cases, anything that can go in here is valid as part of an array. Because we are not going to know. If we have a constant named bar, or like our size, we're not going to know what the fuck that is. And we can do arbitrary sub-expressions to it. So we have to assume it's a type. or rather assume that it can be a type until proven otherwise. So let's try this. I'm going to do this, and then just if we don't have the bar word, do these parse correctly. We are going to say case token kind open bracket. In all cases that aren't definitely a type, we want to bar token open bracket is current token events. Am I using current token? No, we're going to try to not use that. Expect token kind close bracket this. Return new syntax. Index. What I'm going to do is take things here and put them where they most likely exist, which is going to be in statements. So, boom. Then expressions is going to be where I put the statement index. And I can call it like dynamic index or something. Public sealed class syntax index. Need syntax token open bracket. These can be called operands. These are indices. Syntax node. This can go at token open bracket location. Close bracket. And what I'm missing here is syntax node. Sure, LHS. Or value or operand. The thing we care about. So this can be a type if operand can be type. Okay, then children get yield return token open bracket. Close bracket. Yield return operand. And for each var index in indices, yield return index. That's our syntax for indexing things. So we want to return parse primary expert continuation of this, which needs primary token open bracket token close bracket. What the heck? And then I want indices. So then var indices is going to be parse delimited here. Parse any expression. And parsing an expression means we need parse expression context. We're going to parse comma delimited in an expression. Can't have the thing. It'll close with close bracket or token kind semicolon. And that's our index right there. So what does this do for us? No errors. Let's open it up to compare. So inside the compound, we have a binding with an index as the type, the identifier is bar. And then we have a statement expression of just index. Boom. That works for me. I'm happy with that. To do element index access, done. Then case token kind dot. We then want to say we expect an identifier out of our field name, and then we can just return parse primary expert continuation of new syntax field index, which is definitely an expression of primary and field name. So then go back to expression, put it above this. Click field class syntax expert field index field. I could call it lookup instead, but this is. We'll just call it field. We'll keep my terminology shorter. Syntax node, the left-hand side, the value, the operand, sure. I don't know. Target syntax token field token field name is a syntax node at token field name location. Because why the hell not? Public syntax node operand get operand public syntax token field name get field name public string field name text token field text override children give me get operand token field name. Boom. Now I should have this field stuff, so I can go back to here actually. And instead of foo, let's do foo.bar. So then within the index, we should see field, foo.bar. Beautiful. And if I were to do foo.bar here, this wouldn't be a type anymore. So it should fail. Yeah, expected a semicolon. Yep, so it parsed it like this, with a missing semicolon right here. Which is correct enough for me. Okay, so then invocation, open paren, close paren, call it a call, so I can just go copy that from expers index, call, so then instead of open bracket, it's paren. Instead of operand, this is callee. Instead of indices, this is args. So then instead of operand, callee. This cannot be a type. Instead of indices, this is args. And that's a call expression. So then to test, foo, bar baz, foo with nothing, foo, bar baz. Give me 3 call expressions. No errors. Call, call, call. Now, something I've noticed here is callee needs to come first. Operand needs to come first. So I will just flip the order that these are passed in as well. So primary and primary. Not hugely important, but for brain. So we're calling foo with bar and baz. We're calling foo.bar with baz, and we're calling foo with nothing. Beautiful. To do invocation. And we've decided on unlikely ternary. That's most of our continuations. We might have a handful more to add later, but I'm going to call that, like, kind of done. So that's our expressions. We've got a handful of things left to do for expressions, but we've done most of them. I think I'll handle most of the trivial statements off stream, because doing trivial expressions like this for 2 hours was kind of boring. I mean, we got stuff done. It wasn't terrible. We fixed a few problems. We thought a little bit, but I think I'll do the stuff that's easy, like continue, break, go to, defer, whatever, all the parsing for the simple stuff off camera, which might be the rest of it. I have a few more things to do for types, but they're also not terribly complicated. I don't know, I think 4 and 4 each are going to be the most interesting, so I'll try to do them last and maybe stream that. But we might be to the point where we're parsing declarations and or moving on to sema. I have a few more things to do for declarations that all declarations need, these keywords and the ability for template parameters to be applied. So declarations will take me longer, and we might see that on stream. But yeah, statements are going to be more of the same. Everything we saw today is just going to be repeated for statements. Build up a syntax node for it, store trivial to fetch data from it. So I'll do most of that off stream, and we'll come back for the interesting stuff, either sema or declarations. Once we get to sema, we'll be having a good-ass time, I swear. But I'm going to call it there for today. I'm getting a little tired of talking. Thanks for joining in. In the description, you can go join the Discord to get notified, talk to a bunch of other cool devs, and you can find this project on my GitHub, also linked in the description. Goodbye!